Hello. Okay, how's the lab 2? Is everything okay? We are going to release the mark of lab 2 very soon, probably within 1 or 2 days. So please let me know if you have any problem, because like I may not be the person that mark your lab, but if you like have some trouble, just let me know. So just send me an email. And let's go through the lab 3. Okay, so in here, you need to install the Wireshark. I think you have already done it because we have already finished the lab 2. So all we need to do is just open the Wireshark, I reckon. And the first task is to capture the data of RSS data, just like in lab 2, but let's go through step by step. This time just have a little difference, but it's not really hard. So just simply open the let's say Wireshark or network monitor if you're using that one. And if you still remember how to capture the stuff, right? So just simply press this button if you are using the Mac or Linux. But right now I'm using the Windows. Sorry, let me share my screen. Yeah. So if you are using Mac, just simply use the Wireshark to capture, right? And Windows is using the monitor, this one. So what should we do at this time? This time we need to use our mobile phone to create a access point. So in here, because I am streaming right now, so I am not able to do like that, but I can show you in another device. It's in here. So I have a small Arduino that can show the signal strength in here. Just consider this one is my Wireshark, okay? Doesn't really matter. But in your computer, you just simply use the Wireshark or network monitor. But in here, I use a Arduino to show the RSSI right for now. So let me just reconnect it to my mobile phone. Give me a second. I need to change the connection of it. So in here, I will use my mobile phone to create a hotspot. Let me figure out what is my SSID. I reckon it's and the yes, you can consider RSSI as a kind of index for signal strength. We can use the signal strength to calculate RSSI. Okay, now it's attempting to connect to my mobile phone. So my mobile phone create a access point, Wi-Fi access point, called this one. Let me check. Let me have a double check of the name of it. Oh, sorry, I typed the wrong name here. It's 78. So just consider this Arduino stuff is my Wireshark. So in here, I just want to do a demonstration to how to have a look of the ISSI. So waiting for the connection. Now, yeah, it's connected. So my small device is connected to my mobile phone, and they are close to each other right now, less than 5 centimeters. As you can see, the signal strength is around 35 to 40, right? So in here, in the task, we are required to create a Wi-Fi hotspot at first, and then we need to select 10 spots, and each worth, let's say, 1 meters, depends on the size of your room. For example, my room is quite small, only have 20 square meters. So probably 0.5 meters per for each spot. So in the step 2, we are going to move the mobile phone. So right now it's close to each other. And the second step, I will collect some data in here, like for example, collect 1 or 2 minutes. And then I move my mobile phone to a further distance. Now it's 0.5 meters away. As you can see here, the signal strength is 63, 65, right? So the signal strength has decreased. And I move to another place. No, it's become 51, right? As you can see, every time I move to another place, the signal strength is changing. So we can use this feature to discover what is the difference between the distance and signal strength. Just confirming if we cannot find the SSID of the wireless hotspot, would we be okay to use the IP address of the laptop? Yeah, of course, that's fine. That's fine. Just mention this one in your report. Okay. Let me make this clear. For the step 1, step 2 should be pretty easy, but just want to be very clear about that. So firstly, we will have our mobile phone as our Wi-Fi AP, and then we use our whatever the thing you probably a PC or laptop, and then we connect it to the mobile phone. Yeah. And the first time we should have like only let's say 0.5 meters away, and we used Wireshark to collect the data, then you should have an output, right? And in the same situation, we are running the Wireshark, but this time we change it to 1 meter, right? And the third time we are going to change to 1.5 meter, and so on and so forth. We just repeat this stuff for 10 times. Does this make sense? Because as you can see here, every time we move the device away or forward, the signal strength will be different. So we just want to collect all this kind of data. And then you will be able to collect 10 different files like me in here. So I have these 10 files in CSV. So what you need to do is, firstly, you use the Wireshark to connect and collect all the packets you have, and then output as a CSV file. Of course, you need to apply a filter like we did in lab 2, right? And then we want you to plot something in the next step. And another thing to mention is that we want you to have at least 200 ISS data. But we may have some trouble to get enough data like within 2 minutes. So if you can try the first one and see if you have enough packets to plot the stuff. If you don't have enough packets, then probably you need to play a music or play a video when you're capturing the data, or you can also extend the time for collection. And this is the task 1. And in the next task is about the plot. So we want you to plot and discover what is the difference between the ISSI and distance. In here, I have some example in here. So firstly, I just use the pandas to load all the data we have. As you can see, it's in this kind of stuff. This is my data. I can only capture the signal strength, but that's fine. And then I just build this table. So I extract the information from the full CSV file to like this. This time equal to 1, and signal strength is this much. Then I just read all the CSV file I have in here, because I have 10 CSV file. So I just read them all and calculate what is the signal strength average. This one is the count, and then I plot the scatter plot in here. So that's the picture we want. As you can see, it's better to have a line between them. We should have this kind of output. And yeah, so I think it's not pretty hard to plot this kind of stuff, right? So you can use Python or use the Excel if you want, or other language to do this task. But idea is to collect the data like this. Yeah, you can see the RSS, they are not like in a small point. So what is the reason for that? Do you still remember what have we learned in week 1? Because it's a free space, right? So the signal will have reflection from the wall. So with this one, as you can see, it's -20. It's very strong, the signal strength in here. So what happened? Probably it's from the source to the destination directly. But what happened to this one? -43. Probably go to the wall at first and reflect back. So we want to discover what is the average or the median of the ISSI. So you need to calculate what is the signal strength, like the mean value. In here, I use the median, as you can see, like with this table. And one thing to mention is we need to use the log distance. So when the distance equal to 1, so it's log 1, which is 0. And when the distance equal to 10 meters, log 10 is 1. It's we measuring here. Do you mean we have some difference in step 3? I think it's the same, right? The step 3, we need to capture 10 CSV files. Oh yeah, you mean it's difference between lab 2 and lab 3. Yeah, it's correct. So in step 3 of task 1, we need to collect all the data we have like this. So we need to collect 10 for indoor. So I just for example, I'm using Wireshark. For the first one, I just click the button and start capturing. And after a few minutes, probably 2 or 3 minutes, if I have enough packets with signal strength, and then I just stop it and save it as CSV file. And then I move my mobile phone away to, let's say, 1.5 minutes, and then start it again and wait for 2 to 3 minutes and stop it and save it, and so on and so forth. We need to do 10 times for indoor and 10 times for outdoor. So you may need to bring your device to another place. Let's say you can bring your device to a park, to the uni if you want. So finally, you have 10 CSV file for indoor and 10 CSV file for outdoor. So totally 20 CSV files. And this is the task 1. And in the task 2, we want you to plot this kind of thing. You can also plot this kind of thing. So you need to calculate the equation. As you can see, what did I do here? I calculate the equation of this straight line. So just simply use the regression to do the calculation. You don't even need to calculate with your hand. In here, I just simply use the lab MP polyfit. So it's pretty easy to do the calculation. And then plot this kind of line. As you can see, with the longer the distance we have, the signal strength will like goes down. So that's the thing we should be mentioning in our report. So you need to also write down a paragraph about it. Let's see, do you have any question here? Will we do part 2 for indoor and outdoor? Yes. So in here, I didn't show you the outdoor part. You can do it by yourself. It's the same idea. I think use the Excel should be easier to plot this kind of stuff. You can discover this one by yourself. And for the submission here, we need to submit a zip file containing 10 RSS CSV file and 10 CSV file for outdoor. So 10 for indoor and 10 for outdoor. And should be something like this. I will show you an example for that. So this one is for indoor 1 meters. So you have this kind of stuff like we did in lab 2. So you just do this kind of submission. Make sure you have at least 50 signal strengths in each file. Because if it's too less sample, it's not accurate. And in task 2, just upload this graph, both indoor and outdoor, and put it in a report and write down your observation, a comment, and that's it. Do you have any question? And one thing to mention here is the outlier. It's in here. Where is that? It's in the part 2. This one. You can remove them as outlier and fit in the line. So when I'm trying to fit in my line, I find 3 outlier in my part. As you can see here, the outlier is these 3. So these 3 is outlier. So when you do the collection, you may need to maintain the same situation. For example, this one, I put it in the desk, and this one is also in the desk. And this one, I should maintain the same height of the point. And there should have no like obstacles between the mobile phone and laptop. Because for the further distance, I put this one on the ground, and this one is also on the ground. So they have totally different performance compared to this one, because this one is like 1 meter high. So when you do the collection, make sure they have the same height, and there should have nothing between them. Yes, you need to drop the outlier. You need to observe at first, and then drop the outlier. So probably just like I do. Firstly, I just calculate the average here. As you can see here, my average is pretty weird. Start from distance 8, right? Because in distance 7, from distance 1 meters to 7 meters seems pretty good. But when it comes to 8, it's become weird. And I figure out, oh, probably it's because I put my laptop on the ground, while the first 7 is like have 1 meters high. So they have different situation, and that's the reason. So sometimes you don't need to drop it. Yeah, just don't make this mistake like me. So every time you need to make sure there's nothing between them. There's nothing between your mobile phone and your laptop. And make sure they have the same height. So if you are putting your mobile phone on the ground, then always put it on the ground. If you keep it on the like 1 meters high, probably put it on a table or something. Then always make sure you have the same height when you do the collection. And that's it. So try not to copy my code in here. You can do it by yourself at first, but if you do not know, to just have a look. So this time I will not upload my code to the GitHub. But yeah, but I have already shown you in here. So if you do not know how to do it, just come to the recording. I'll upload the recording after this time. Yeah, so basically that's all the thing we need to do in lab 3. It's not pretty hard, isn't it? But it's pretty fun to discover the like relation between the distance and signal strength like this. You can if you have this kind of device like Arduino or Raspberry Pi, it will be easier to do the collection. So you can have a look of the signal strength in the real time. Yeah, I think that's all for the lab 3. If you have any problem, just let me know. Probably you can start from now. Try to do the task 1 and let me know if you have any trouble. Let's say you can try to do 3 collection for 1 meter, 2 meter, and 3 meters. And then you go to the step 2 and try if you can plot the stuff. If you have the trouble, then let me know. And feel free to share your screen and ask me the question. And one thing to mention is the GitHub link. I will upload so the GitHub link is in here. In lab 2, everything's okay. Yeah, just ask me some question so I can know what to write in for lab 3. And how was the quiz from last week? Is it still hard? Not enough time. Yeah, that's pretty normal because the calculation. Yeah, that's good. So in the GitHub, I will also upload some information for week 3 quiz because I don't know what will be tested in the quiz, but I will try to like point out the important knowledge that we have learned in the week. So that's usually we want to test because last week is all about path loss calculation. So we have 2 ways to do the path loss calculation. Depends on the break. So you need to know how to calculate the deep break. Then you know which kind of method are you using. Okay, so that's it. I will try to do my best to help you. Oh, week 3's content is much harder. Easy? I think it's easier because it's less calculation. I think you are too good at calculation. Yes, definition is easier, right? Because it's you can do Google search. So in here, just let me know if you have any trouble with the lab 3. I will stop my sharing right now, and you can stop sharing if you have any trouble.